back. Today we're going to be looking at the more advanced aspects of the splitter tool. So to begin, I went ahead and already dragged in the prefab that we made last time. If you go to modular character parts, skin split prefabs, you can go ahead and just drag that prefab back into the scene. So here, you'll see that I have that prefab with all the mesh parts that we separated last time. And here's the original asset that I was using. I went ahead and chose a different skinned mesh to use. So last time we were using the male, this time we'll use the female version. I'm going to go ahead and drag and drop her in the source skin mesh here. But this time we're going to use a custom prefab. So for the custom prefab, you can use other prefabs essentially as where you want your split skin mesh to go. I call them your target prefabs. We're going to try two different ways. The first thing we're going to do is we're going to target the prefab that we made during the previous video with all of the mesh parts on it. You can see here that there's actually a field for the target skin mesh as well as a bone hierarchy prefab. So starting with the bone hierarchy prefab, that's just going to be what prefab you're trying to target. So where you want that split mesh to be. So I went ahead and dragged and dropped it in the prefab field. Now for the target skin mesh, that's going to be where all of your references for your bones are pulled from. It can be any one of your skin meshes. It doesn't have to be a full skin mesh. It can be a part. So I'm just going to drag in the chest and drop it right here. Okay. The next thing you want to look at is the prefab root bone name. So for us, it's the same. Senti does a good job at keeping the naming conventions the same across prefabs or across asset packs. So you can see here, this is called root. This is your root bone hierarchy. Specifically what we want to look at, we want to look at the root bone hierarchy of the target prefab for the root bone name. All right, so now we know, okay, this is where it's going to pull names from. We'll do a round of deformation later, so don't worry about that. I'm going to keep everything else the same. I'm going to click validate, and then I'm going to load bones. This load bones section here, what it's doing is it's taking your source bones and the target bones, and it's comparing by name. And we want to look through it and just make sure the things that have the biggest effect on the animations are named the same. You might see things in here that are like this hair, for instance. I can show you where that's coming from. So we look at the hierarchy, it's the source bone hierarchy. The hair is actually coming from, if I keep dropping this down, actually this might be, well, if I keep dropping this down, we'll see here on the head, there's hair and a mask. Those are skin meshes that'll still show up in here because it thinks they're bones because they're in that bone hierarchy. So if you see those, don't worry about it. What we really want to do is just make sure that the primary bones do align in name. So if spine _01, spine _01, and so on, just go down the hierarchy and make sure that the naming conventions are the same. So here you can see clavicle _left. For the source, it's also named clavicle _left. And again, because I'm using assets from the same developers, they almost always use the same naming conventions. But I'll show you later a situation in which, you know, the naming conventions might be different, and we'll talk about that. But let's go ahead and apply names and then load the mesh in. Okay, so this is that female mesh that I told you we set as the source. So just like the workflow before, we'll have groups. I'm not going to make as many groups as I did last time. I'm just going to show you real quickly how this works. So we'll start by making boundaries like we did last time. take a seed, put some seeds here, process the group. Okay, so now we have a hand. Let's also do the head. So we'll add another group here. Plant some seeds. Get all of our missing triangles from that group. Okay. So what we'll do next is we'll go ahead and separate. And instead of creating an entirely new prefab like we were seeing before, it'll update the prefab that we're targeting. So if I look at the prefab that we made last time, you can actually see there's going to be a much larger section that's ungrouped just because we only split two things, right? We split a head, which now, based off that group name, it's going to find the container for all the heads of each character. Go ahead and remove this one. There you go. That's her, but with all of the guys mesh stuff. So you can use her head on the guy's body. Okay, so now what I'm going to do is I'm going to reset the fields. So this time we're going to be doing something a little bit different. We're going to still choose a skin mesh to split. So I'll go ahead and drag it in there. But this time we're going to use this. So this comes from a completely different asset pack. So you can start to see how this can be really useful for creating modular parts, right? So I drag this guy in here. And I'm going to drag in the target skin mesh. Again, it just gets the references to the bones. The names of the roots are still the same, so we can keep that. And we'll go ahead and validate. Okay, we're going to load bones. All right, now looking at the load bone hierarchy, we can already see that there are some discrepancies in the naming conventions. If you look at the target bones here, they're actually reusing the same name. So finger 01, finger 02, yada, yada, for both hands. Whereas our source is using different names. So what I've found is that it's actually better to have different names rather than the same name in order for this to work, because then it won't get confused on what bones belong to which part of the body. So, for instance, which fingers belong to which hand. All right. Now, in a typical workflow, you would want the source bones to match the target bones naming convention. But in this case, because our target bones are using the same names across both hands, we're actually going to want to update those names. So all you have to do, and this is a bit tedious, maybe I'll come up with a better solution, but I just copy and paste. Make sure you're following the same hierarchies down the list. But as I start to copy and paste, you'll see that the names change green. And that means it's found a suitable associating bone. And again, remember what I talked about last time. Sometimes there is just some straggling skin meshes, represents like things like earrings or hair or whatever. You can ignore those. Those won't be a part of the animation, so those don't matter. All right, we're going to go ahead and apply. Now, when you apply, it actually updates the asset's actual naming here. So if I go into the scene hierarchy and start dropping down here, you can see that the names were changed. Now, if I want to, I can override so that that stays permanent. So just be aware, because the original developer is using different prefabs for every skin mesh. If you use a different skin mesh, you would have to update it every time. So I would just pick one that you're using as that target prefab, and then just stick with it. So you only have to do the naming convention stuff one time. All right, now that those are applied and overridden, I can go ahead and load in the mesh data, which is going to bring in the character that I selected as a source. And we can start working like we did last time for adding new groups. Just in the same hand. Okay. So here's where you might start to experience some weird stuff going on. And we're gonna talk about it. We're gonna fix it. But I just want to show you, if it does happen, what that mistake might look like. Okay, so we have the boundaries as usual. We have the seeds. We're adding them. We process the group. Now pay attention to this component right here. Okay, so it wasn't egregious. However, you can see that this was added. That's because for the proximity threshold, it doesn't discriminate direction. And that's important because sometimes we might have a complex mesh that does have, some triangles over top of another that we want to be in the same group and work with the flood fill. Obviously, with this mesh, we wouldn't want to add this component to it, to our group. So playing around with the proximity threshold could prevent that, but it might actually prevent your triangles from reaching the correct areas in the grouping area that you want to work. So that's just something you have to experiment with on your own. But in our case, yeah, it seemed like it wasn't that bad. Let's go ahead and make another group. This time we'll start by changing the color. Again, I don't like it when the colors are the same, just in case I need to use the unprocessed group. We'll call this one arm _ right. I actually named this incorrectly. Let me fix that. Okay. So just like our last time we split the arm, we want to find an appropriate part to split, or appropriate section. Somewhere that makes sense in terms of splitting the arm and then making that the modular component. So in my case, I split it right here. It makes sense for how we did it on our other asset. So that's how I'm going to keep it. Then for this, we can just add some seeds here at the bottom. Again, because we have topology that's a bit more complex, you might want to add some to the outward faces here, just so it will 100% reach. Even if it doesn't, we can go back and fix, but let's process this and see if anything was missed. So just by looking at it, looks like nothing was missed. Perfect. Okay. So we'll go ahead and separate these parts and save. All right. Now you can see that our target prefab now contains the parted meshes that we just created. So again, that was for demonstration purposes. It's so you can be familiar with both workflows. You can see here that, yes, it does exist. If I remove these, or if I disable these parted meshes, you can see the underlying skin mesh that's still active underneath. Right? I can turn that one off. You can see that one. Yeah, so it looks like the things we were running into, the skin meshes that were still present, were actually their own parts. So like This hair is already separated. This face mask, stuff like that. Let me go ahead and reset our window here. For this next part, we're going to look at the different options for deformation. And we're going to be adding the separated parts onto the prefab that we used earlier. You might notice that those separated parts aren't there anymore. It's because I deleted them. So just be aware of that. You're not going crazy. I just did that off camera. Let's go ahead and start by bringing in a couple of characters that might not be the same size as the character we want to work with. I'll go ahead and bring in this mummy character. If I move this guy back to 000, you'll see here that it is significantly bigger than that character. And what we're looking at here is not a simple scaling change. It's not a scaling difference. Look at both of them. They're both at 111 on their scales. If you actually look at the skin mesh, which is even more important, the scaling is still the same, 111. So what does that tell you? It tells you that they are the correct size and Unity's standard scaling. It just means it's a smaller mesh. It's a smaller character. So what we want to do is actually look at resizing that character to kind of fit more of the proportions of this character. We'll start by adding the mummy as the source skin to mesh, because again, that's the one we want to work with. And we will use custom prefab, and we'll drag and drop the cyborg into the bone hierarchy prefab, as well as the skin mesh as our targets. This time we're going to allow for deformation. Now by default, it uses the pose-based deformation. In the manual, you might read something about, what is more preferable depending on what size change you're doing. That's because going from small to large is different than going from large to small in terms of how these deformation algorithms work. So when you're going from small to large, you want to use a pose-based deformation. If you're going from large to small, you want to use the lattice approach. Now, in our case, we'll go ahead and stick with the pose-based because we have a character that we want to make larger. So we'll start doing the same thing as we did last time by validating and then loading in the bones. Let's take a look at what the naming conventions are. Let's see. So eyebrows. So it looks like the kid's eyebrows and eyes are different. There's a designated left and right, whereas our other character only has a singular, which is fine. We don't have to touch any of that, okay, because it's not important to the animations we're trying to be working with. Let's go ahead and apply the names now and load in the mesh data. So now we have our character. Eyes are missing. That's fine. We can add them back. Post-process. Go down, add new group. This time, instead of doing any kind of highlighting, which you can do, you can split this mesh if you want. But what I'm going to do is I'm not going to split it at all just for brevity's sake. Click Allow Ungroup Triangles to be made into their group mesh. And then click Separate Parts and Save. This makes it so that you still have that model. It just doesn't have any kind of designated group. So it'll separate it into ungrouped like we've seen before. Get rid of him just so it's easier to see visually. And you can see here that now we have this mummy character who is about the same size, at least height-wise, as this character. There might be some differences in terms of bulk. The head is clearly smaller here. But we have a good deformed prefab. And then if we wanted to, we would add the eye back here. I'm not going to do that just to keep it short. So that's how you use the post base deformation. Okay, so now we're going to do the lattice-based approach. So what I'm going to do is I'm going to pull in a character that is larger than the character that we want to be the target. I know specifically in the Wasteland pack here, there are characters that are much larger. We'll go with the mutant. Okay. So height-wise, they're about the same. The heads are in a slightly different position here. The larger character's head is actually, looks like it's smaller on the Z-axis, on the back of the head. You see the feet, significantly different. And the arms. This is why I chose this character, to show you that the arm distance is, and just bulk, is a lot different. So here we'll do the same thing we did with the mummy, is we will drag in the skin mesh as our source. We'll drag in the cyborg as our prefab and as our target. Okay, so last time we did this, we used pose-based deformation. This time we're going to be using the lattice-based approach because we're going from larger to smaller. Keep the lattice resolution at 300. I find that for me, this is perfectly fine. It does control the fidelity of how close to its original resolution the mesh will keep. But if you begin to experiment and go higher, you could potentially crash your application. So I would keep it at 300. I haven't seen any issues with 300. It seems to work fine. Now, granted, you're going to have to test that out with your setup. We'll validate. We'll load bones. Okay, so there's some things here I wanted to show you. First thing, if you look here, you can see that the belly exists on the source. So that would be our mutant. The belly bone exists and does not exist on the target. What this means is if you have animations that use a belly, those animations will not use the belly, right? But this will not break this conversion here. It just means that portion, that weight won't be used. That's okay for this instance. But if this is happening all over, like if you have a tail or, other parts that are a bit different than a normal human, you might start to see some really strange things happen with your animations. So just be aware of that. Try to keep the target and the source to have a similar bone hierarchy so you don't have that loss of animation data. But in our case here, it's not that big of a deal. So we're dealing with the same issue we had before, where the naming convention is that this mutant has the same names for the right hand fingers as it does for the left hand fingers. So we're going to go ahead and just copy what the target is doing in this case. And as I scroll down, you can see that there are some of those other skin meshes on there that we can just ignore for now. Let's go ahead and apply names and load our mesh data now. All right, we're going to do the same thing we did last time, where we're adding a new group, but we're not actually selecting any groups. You can if you want. For me, I'm just going to separate the parts and save it. You can see here, once I showcase the cyborg guy, you see that the character was deformed to match the general size and shape of the cyborg male, with some differences, right? So those differences being, you can see here that it's not retaining the same width as it did before. This is intentional because the idea is that you can use this mesh as dynamic parts with your other meshes. So yes, it does shrink things down and make it look a little bit more strange than it did before, right? You can see here that the head is obviously much more flattened out. In proportion to its previous shape, however, this is actually exactly what should happen. Now, if I wanted to, let's say, like split something on here, you can see that it's going to more closely match the original. So let's say I wanted to use like the legs, for instance. Those would be much more, it would be much more possible to use this as modular parts this time around than if it was to keep the same width and proportions. So that's why we do it this way. And what I like to do from time to time is just press play here and make sure that the animations are working, and that there's no very strange deformations in the animations. For now, that's all I'm going to be talking to you about today, and I will see you in the next video.